Okay, let's take a look at another bending moment question. The reference for this question is going to be in your 3A1 textbooks, Chapter 6, page 33, self-test question number 11. Now I'm going to modify this question slightly. As you can see on screen here, I've crossed out the last little bit of this question. And the reason for that is that this question is very lengthy, and you basically have to do the question twice and then just compare the bending moments from both halves of the question. Well, if you can do it once, you can certainly do it twice. So I'm going to do the first half of this question to get our bending moments halfway across the beam, as indicated on my diagram here of XX. Well, down in my diagram, we've got a 15-meter long beam with point loads of 50 kilonewton, 90 kilonewton, and 200 kilonewton at distances of 3, 7, and 9 meters respectively from the left-hand end. Our section XX, indicated as the dashed red line here, is going to be exactly halfway across the beam, and half of 15 is going to give us that 7.5 meters. So our distance from here out to R2 here is 7.5 meters. And we want to find the bending moment. All right then, to start off with, we need to find the reaction forces at R1 and R2. So to start off with, we're going to take our statement and we'll take our moment about R1. Now, once we take our moment about R1, we can now say that our clockwise moments must equal our anti-clockwise moments in order to get equilibrium. So, moving to the right of R1, the first force that I get to is 50 kilonewtons. Well, that 50 kilonewtons is most definitely acting clockwise on R1, as it's wanting to spin our beam in this direction. So, adding that into our equation, it's going to be 50 multiplied by the distance from the 50 kilonewton to R1. Well, that's on my diagram of 3 meters. We can now go ahead and add our next moment. Moving to the right of the 50 kilonewton, the next force that we get to is 90 kilonewtons. That one is also acting clockwise to R1, so we can pick that one up. That's now going to be 90 multiplied by the distance from the 90 kilonewton back to R1, which once again is noted on our diagram here of 7 meters. We can now go ahead and get our next clockwise moment. Moving to the right of the 90 kilonewton, the next one we hit is 200 kilonewtons. That 200 kilonewtons is also going to turn, with respect to R1, clockwise. So adding this onto my equation, we're going to get 200 multiplied by the distance from the 200 back to the R1. Well, once again, that's on my diagram. That's indicated as 9 meters. Those are all my clockwise moments. Next, what we've got to do is jump onto the right-hand side of the equation and pick up our anti-clockwise moment. Well, looking back at the diagram again, the only anti-clockwise one that we can see here is at R2. That would turn anti-clockwise with respect to R1. The problem is here, though, of course, I don't know what R2 is, but I do know how far R2 is away from R1, and that's 15 meters. So I can simply say that my anti-clockwise moment is R2 multiplied by 15. Okay, there is my great big long equation, which we can now go ahead and start to simplify. So my 50 times 300 is 150. My 90 times 7 is 630. My 200 times 9 is 1800. And on the right hand side, we can simplify that to just 15R2. Now, if we add the left hand side together, 150 plus 630 plus 1800 gives me a left hand side of 2580 newtons, and the right hand side stays as 15R2. We can now rearrange this for R2 is equal to 2580 divided by 15. That will now give me an answer of 172 kilonewtons. And there is my first reaction force at R2. Now, at this stage of the game, if this was an exam question, for example, I wouldn't bother going ahead and getting the other one. And the reason why is that if I have R2, I would simply now just look to the right of XX and away I'd go to get the bending moment. However, because we're using this as practice, let's just go ahead anyway and get what R1 is. So once again, I'm going to use my second statement of upwards forces equal downwards forces. And my upwards forces, going back to my diagram, are my R1 and my R2. Well, R1, I don't know what that is. So we leave that as it is. And when we add this to the one we just found for R2 of 172 kilonewtons. Looking back at my diagram, I now want the downwards forces. Well, there are three of them. There is the 50, the 90, and the 200 kilonewtons. So let's add all of those up. 50, 90, and 200. Okay, we can now go ahead and simplify the right-hand side of my equation. There's 50 plus the 90 plus 200, and that gives us 340 kilonewtons on the right-hand side. And the left-hand side stays as it is for the moment. We can now go ahead and rearrange this and say that R1 is equal to 340 minus 172 if we take that on to the right-hand side. That would now give us an answer for R1 as 168 kilonewtons. So there is our second reaction force. Okay, we've now got both reaction forces, so we could go left or right depending upon how you're feeling. So looking back at the diagram then, to make that decision, if I look to the left of XX, looking this way, we can see that I would have to pick up three forces to do a bending moment here. That force would be the one at R1, the 50 kilonewton, and the 90 kilonewton if I look to the left. If I looked to the right, however, I've only got to pick up two forces, and that's the 200 kilonewton and the R2. Well, 2 is better than 3, it's less work, so I'm going to choose to do my bending moment to the right-hand side. So we'll keep it much simpler. So let's do that. So down here then, in fact, let's do it over here underneath so we can keep our diagram slightly visible. So then, my bending moment, looking to the right, just to keep things a little bit easier, the first one moving to the right of XX is my 200 kilonewton, and we can see with respect to my section of XX here, it would turn the beam in a clockwise direction. Well, remembering from earlier, clockwise directions for bending moments are positive and anti-clockwise directions for bending moments are negative. Well, this 200 here is a positive, so let's give it a positive sign. So that's plus 200, and now we need to multiply that by the distance from the 200 kilonewton back to XX. Well, we can see on the diagram that the 200 kilonewton is at 9 meters from the left-hand end, and section XX is 7.5 meters because it's halfway from the left-hand end. The difference between 9 and 7.5 is 1.5, and that there is our moment basically of force multiplied by distance, and that's exactly what our moment is. Let's now add that to our next one. Well, our next moment that we get to is going to be the R2, but you can see on my diagram it would be turning anti-clockwise with respect to section XX. Well, anti-clockwise ones get given a negative sign, and we found R2 over here earlier. R2 was given as this 172 kilonewtons. So let's put that into the equation. 172, and now multiply that by the distance from R2 back to section XX. Well, that's easy. It's halfway across the beam, and half of 15 is 7.5. So there's my equation right there. If we now stick this in and simplify it down, the left-hand side of 200 times 1.5 is going to give us plus 300. And the right-hand side, watch out for the negative sign now, we've got minus 172 multiplied by 7.5. So that's going to give us minus 1290. If we now simplify that, 300 minus 1290 is going to give us minus 990 kilonewton meters. The unit is in Newton meters because it is a moment, and that is a force multiplied by a distance. So our 990 kilonewton meters, if it's indicated by a negative sign, means that on the right of our section XX, our moment is going to be going in an anti-clockwise fashion. So as before, we could describe this as 990 kilonewton meters in an anti-clockwise direction to the right of section XX. Therefore, if we would have chosen to go to the left, we would have got plus 990 kilonewton meters going in a clockwise direction. Now, if you want to go ahead and finish this one off, all you've got to do now from the textbook is add another load dead center, recalculate your reaction forces, get the bending moment again, and then determine the difference between the two. I'm sure you can finish it off after seeing me do the first half. So hopefully that gets you well on the road to completing this one, if you are having any problems with it. But again, it is a fairly lengthy question. Hopefully this helps you out, and then I'll see you again for another video very shortly.